The facts are simple but impressive. Of the nearly 6.5 million kilometers of highways, roads, and streets in the U.S., about 2 of every 5 are unpaved and carry over 1/5 of all traffic. Most of these unpaved roads are aggregate surfaced, that is, covered with a layer of gravel. Although you won't find any gravel roads in our interstate system, you will find them making up a large part of our local roadway networks nationwide. And while gravel roads generally carry low volumes of traffic for short trips, they nevertheless are used for a wide variety of purposes, and sometimes by very heavy vehicles. Because they are essential to the local transportation of people and products, gravel roads need to be maintained in good condition. Their users deserve a safe and reasonably comfortable ride. In reality, though, conditions are not always good, and the rides not always safe nor comfortable. The reason? Scarcity of road maintenance funds? Yes, in part. But there's always a shortage of public works money. Beyond the dollars, many local agencies also lack an understanding of the causes of gravel road problems and are unaware of the proper methods for preventing or correcting them. Then there's the ever-increasing abuse we heap on our gravel roads. Some of the stupendous wheel loads inflicted on them nowadays would be illegal on even our sturdiest pavements. This video presentation was produced as part of the Local Technical Assistance Program of the Federal Highway Administration. Its objective is to help local agencies recognize common problems of gravel roads, understand their causes, and learn how to prevent or correct them. A handbook has also been developed as part of this training course. The video is in 3 parts to allow an opportunity for discussion after each segment. In this first part, we'll examine the environment of gravel roads and the aggregate materials used to surface them. In Part 2, we'll focus on the common problems of gravel roads, what causes them, and how to prevent or correct them. Then, in Part 3, we'll look more closely at maintenance equipment and techniques. Now, just what is a good gravel road? Well, those who get the angry phone calls from upset citizens might describe it as one that doesn't have ruts, potholes, or loose gravel, one that drains well and isn't dusty, one that's smooth but never slippery. Of course, it also must be wide enough for vehicles to pass without driving into the ditches, not too steep, and not too curvy. Oh, and by the way, when are you going to get around to paving it? Well, you can't deny that most people prefer paved roads, nor can you blame them. Many even argue that good money shouldn't be wasted on gravel roads because it's like trying to make a silk purse out of a sow's ear. But people's attitudes aside, we're not likely to see most of our gravel roads paved anytime soon. They've been around a long time and are here to stay. Like paved roads, gravel roads should be constructed to minimum design standards and maintained that way as long as possible. They should have a traveled way, a shoulder on each side, and roadside ditches. Their surface should have a modified A-crown, with the travel lanes sloping down from the center of the road for drainage. The surface layer must be strong enough to prevent overstressing the subgrade, stable enough to resist raveling, shoving, rutting, and consolidation within the layer, and smooth and skid-resistant enough for a comfortable, safe ride. Gravel roads are greatly affected by their surroundings, from high mountains to low coastal areas, from cold regions to hot environments, from wetlands to deserts, from hills to flat terrain, and from open countryside to dense forest. But with all this variety in their environments, the most influential factor of all is moisture. A wise old sage once observed that there are 3 keys to maintaining any road: drainage, drainage, and drainage, in that order. Seriously, though, there are 3 important aspects of drainage: getting water off the road, out of the road, and away from the road. Do all three, and you can maintain any gravel road. Getting water off the road is the function of the road's crown and cross-section. A properly sloped surface allows the water to flow off the traveled way, down the shoulders and foreslopes, and into the ditches. Getting or keeping water out of the road is accomplished by maintaining the surface free of flat areas, obstructions, and depressions that will hold water until it weakens the gravel layer and penetrates into the roadbed. Keeping water out is also dependent on building the road at the proper elevation so that it's above the water table. Getting water away from the road is the function of ditches and culverts. Ditches carry the runoff alongside the road until it outlets into culverts, streams, or holding areas. Water, however, is not always an enemy of gravel roads. In fact, in the proper amounts, it's a vital ally, as you'll see in a minute. Perhaps the most important element in the success or failure of any roadway is what it's made of. Material characteristics determine how well and how long the structure will function. Mineral aggregate is the primary component of gravel roads. Crushed stone, gravel, and natural sands are the most common types of aggregate. But with other mineral materials plentiful in many areas of the country, and some areas lacking natural materials altogether, you'll also see slag, shale, chert, crushed basalt, shell, and even some natural soils in use. Not all kinds of gravel are good for road surfacing. Some types break down into fine particles under heavy traffic. Others swell when wet. Still others are so hard they're difficult to work. Good gravel supports the weight of traffic and distributes it enough to protect the subgrade. It remains tightly bound in dry weather to resist dusting and also sheds water in wet weather. Furthermore, good gravel for road surfacing contains a blend of particle sizes. The different sizes packed together, with smaller ones filling the gaps among the bigger ones to form a dense interlocked mass. On the other hand, gravel with particles of all the same size won't pack together into a dense stable mass, but will remain loose. A good blend of particle sizes is a gradation that ranges from a maximum size of about 20 millimeters down to very small or fine material having the consistency of flour. In fact, the difference between the gradations of good base course gravel and good surfacing gravel is the presence of more of these fines in the surfacing material. Because of it, surfacing gravel is sometimes described as dirty. The fine material serves two essential purposes. First, by filling the voids among the larger or coarse aggregate particles, the fines act as a binder that holds the total gravel mixture together and helps it form a dense, tight mass when the water content is correct and compaction is applied. A measure of this binding ability is called plasticity index, or PI for short. The higher the PI, the better the binding effect. Second, fines are also needed for their crust-forming ability. A hard, tight surface crust on a gravel road bears traffic loads and sheds water. A minute or two ago, it was said that water can be an ally of gravel roads. In fact, to form a hard, tight crust, water is essential. That's because the fines need moisture to turn them into the cement that binds the larger particles together. Another characteristic of good gravel for road surfacing is angular shape. The particles need to be angular, have sharp edges and flat faces to interlock properly. Angular gravel occurs naturally in some areas, or it's a byproduct of manufacturing, such as slag, or it's produced at crushing plants. But in many parts of the country, natural deposits of stone and gravel consist of rounded material. The rounded shapes of such gravel don't allow it to compact and interlock well, even with the presence of sand and fines. Rounded gravel particles act like marbles or ball bearings. Imagine trying to form them into a tight, stable layer. You just can't do it. The control and handling of gravels greatly affect their suitability for surfacing roads. Pit, crusher, stockpiling, and blading operations can either help or hinder the quality. Some examples. At gravel pits like this one, loader operators should remove material from the full face of the pit wall to obtain a complete and uniform blend, not from a narrow band. Crushers need to be set up and operated properly. For one thing, they need to be level. A plant that's out of kilter may segregate the crushed material, that is, separate the particles by size so that the material is not uniformly blended. Also, the screens must be in good shape, not clogged or full of holes. Faulty screens may allow oversized stone in the gravel or interfere with the desired gradation. Stockpiling practices can affect gravel quality too. Start with the basic site. It should allow for proper drainage and be cleared of debris and vegetation so that the gravel isn't contaminated when it's placed there. There should be ample room to place stockpiles of different material without having them intermingle. As much as possible, stockpiles should be built in layers rather than in cone shapes. Cone-shaped piles allow larger gravel particles to run down the steep slopes and segregate from the rest of the material. Removing the gravel from stockpiles is important too. Loader operators should keep their buckets above the bottom of the pile to avoid picking up any base materials such as clay, oversized stones, vegetation, etc. Loader operators can get a better blend of gravel from the ends of stockpiles rather than from the side slopes. This way, material can be taken from the pile's full cross-section. Even during blading, the suitability of the material is affected by the angle and pitch of the grader's moldboard. But more on this later. For now, we'll stop right here. Recognizing the environments in which gravel roads function, understanding the characteristics of the materials they're made of, and knowing that there are right and wrong ways of working with these materials are a good beginning to dealing with the problems associated with gravel roads. In Part 2, we'll look at those problems, including their causes, prevention, and correction. Anyone who drives a lot on gravel roads is familiar with their problems. Some roads are more susceptible to these problems than others because of deficiencies in the road's materials, the nature and extent of wear and tear by traffic, and the weather, poor geometric design, or poor grader operation during maintenance. Here in Part 2, we'll look at the 3 most common problems of gravel roads, including their causes, prevention, and correction. First, corrugation, then loss of material, and finally, rutting. Corrugations are the transverse ridges that usually extend across the full width of the traveled portion of the road, running perpendicular to the direction of traffic. In many parts of the country, this distress is also called washboarding, and it's not hard to understand why. The ridges remind you of an old washboard, both in appearance and feel. Especially feel. They'll rattle your bones and loosen your fillings. Drive on them any distance, and you'll swear that your car's coming apart bolt by bolt. And you with it. But the term corrugation is pretty descriptive too, as in corrugated paper or corrugated pipe. Regular undulations forming alternating ridges and valleys. Sounds lovely when you're thinking of the Appalachian Mountains. But it's aggravation mountains to drive on. The ridges may be as high as 50 millimeters, with less severe washboards measuring lower. The distances between ridges typically measure 150 to 200 millimeters. Corrugations can cause violent vibrations in moving vehicles and seriously decrease the driver's control of steering and braking. So we know what corrugation is, but what causes it? Well, first of all, traffic. More precisely, it's the oscillating action of vehicle suspensions and tires that forms the surface ripples. Increased vehicle speed apparently hastens and enlarges their formation. Even different tire inflation pressures seem to affect their rate of development and severity. Hard braking and quick acceleration are causes too. Wherever traffic tends to stop abruptly or start rapidly, you're likely to find washboards, such as at stop signs. Besides traffic, though, washboard formation is related to the gravel's gradation, road conditions, road locations, and even motor grader operation. In terms of the gravel's gradation, corrugations tend to form when the gravel contains too few fines. In other words, too little binder material. The fines may be insufficient either because they weren't in the gravel originally or because they had gradually dusted away or washed away. Even when the gravel's gradation is good, road conditions may not be. Excessive dryness creates dust that results in the loss of fines. Steep grades or crowns may allow fines to be washed off by rain. Either way, the loss of fines leaves the remaining gravel susceptible to washboard formation. Soft roadbeds and pothole surfaces encourage washboarding too. Certain locations along gravel roads are more likely to develop washboards. Intersections are prime candidates because of traffic deceleration and acceleration, as are hills, curves, and driveways. Finally, improper motor grader operation during routine maintenance can lead to the formation of corrugations too. Operating too fast or in the wrong gear produces machine oscillation that causes the blade to leave ridges in the surface. This type of corrugation is easy to detect because the ridges are diagonal, matching the blade angle. To avoid making them, grader operators should run between 5 and 8 kilometers per hour, work in the proper gear, use the correct blade angle and pitch, and inflate their tires correctly. Now, as for preventing washboards, the only sure way is to close the road to traffic permanently. The only preventive measure you can get away with, however, is to make sure that the surfacing material has enough fines in it. Some agencies are fortunate to have gravel with adequate natural binder. Other agencies must adjust their crushing plants to process material with sufficient fines. Still others have to add extra fines to their gravel or a commercial binder such as road oil, base seal, or soil tight. Having gravel with enough fines is essential, regardless of how easy or hard it is to obtain. Of course, even with the best material, washboards tend to form in gravel roads, especially at the locations identified earlier. So what corrective measures can be employed? For light washboarding, where the corrugation heights are under 25 millimeters, routine blading or dragging will remove the problem. Motor graders are typically used to do this smoothing, but drags, rakes, and underbody truck blades may be used instead. Moderate and severe washboarding have ridges that are not only more pronounced, but also more difficult to correct. Merely clipping off the high spots and filling in the low ones will not solve the problem for long, because the corrugations tend to reform at the same locations in a matter of days or even hours. Instead, scarifying and cutting the surface is first called for, to a depth just below the bottom of the corrugations. Then, adding natural or commercial binder, adding more gravel if needed, and finally, mixing the materials and reshaping the surface. Because corrugation may be concentrated at certain locations, spot correction is frequently called for. Care should always be taken to blend the corrected areas into the adjacent roadway. Correcting washboarding after rains is always a good idea, since moisture is needed to compact the regraded material and form a tight surface crust. Whether the regrading is extensive or in limited areas, the roadway crown and cross slope should be maintained everywhere, and good transition should be made at bridges and intersections. The next problem is loss of material. We're talking about aggregate material that is either removed from or displaced within the roadway. Basically, it can be lost in three ways: by dusting away, by raveling, and by a process we'll call sinking. Let's look at each. Dust, of course, is created by dryness, whether it's an arid region, a dry season of the year, or just a rainless spell of weather. All gravel roads produce some dust in dry conditions. Dust is created when the fines portion of the surface gravel dries and loses some of its binding qualities. Tire action breaks up the surface crust, separating the coarse and fine particles and lifting the fines as dust. While some dust settles back onto the road surface, much of it ends up on the road side, on adjacent properties, and of course on the vehicles that raised it. It may be hard to imagine losing much material in these billowing dust clouds, but research shows that as much as 25 millimeters of surface material is lost each year from dusty roads, or in other terms, about 70 metric tons per kilometer. Of course, this varies with the amount of traffic on the road. Such a loss is certainly significant because that material is needed on the road. Whatever amount is lost, an equivalent amount, especially fines, needs to be put back. But the cost of replacing lost material is not the only drawback. Dust is a nuisance. It's not pleasant and it's not healthful. Property owners along dusty roads don't like what it does to their homes, crops, livestock, and businesses. Then there's the safety issue. For those who drive on dusty roads, visibility can range from poor to zero. But the problems don't even end there. It's not just the replacement cost, safety, health, and nuisance issues. Severe dust also means that the binding material is removed from the surface, leaving the remaining gravel susceptible to washboarding and a further loss of material. This further loss is what we'll call raveling. With the road's crust breaking down and too little binder remaining, the larger gravel particles loosen and separate. Traffic easily whips them out, kicking some off the road and leaving the rest displaced on the surface. Typically, this gravel accumulates along the road in longitudinal ridges that run in the direction of traffic, between wheel paths, and on the roadway edges or shoulders. Loose gravel also tends to accumulate where vehicles regularly stop or turn. Raveled material means that the road surface has broken up and isn't performing its intended function. The loose gravel also creates poor traction and steering, and often results in cracked windshields. A couple of things can speed up the process of raveling. Rainfall, for one. It further erodes the fines and washes them off the road. Also, steep grades and excessive crowns allow gravity to work with rain and tire action to further separate the loosened gravel. Finally, another form of material loss is the sinking of surface gravel into soft, excessively wet roadbeds, especially ones containing a lot of clay or silt. Field observations show that tremendous amounts of gravel can be lost into subgrades at such locations. If the situation isn't corrected, the gravel will continually have to be replaced. So how can you prevent aggregate material from being lost? Well, to prevent or at least delay dusting or raveling, be sure that new surfaces have enough binder. And try to compact them with a roller, usually after adding water, to produce a tight, impervious crust. Through time, however, the effects of weather and traffic are likely to disturb any crust, resulting in loss of fine material and eventually raveling. Corrective measures for dusty or raveled roads start with replacing the lost material. Fines often can be reclaimed from the shoulder edge and regraded and mixed with the existing gravel. This operation should be done as routine maintenance along with restoring the road's crown. Basically, however, dust is effectively combated only by adding something to the road surface. Palliatives or dust suppressants are needed. Water is the simplest and most environmentally acceptable suppressant, but you can't always count on nature to apply it when needed. And for maintenance crews to apply it, the amounts needed and the equipment and worker allocations required make it prohibitive. So commercially available suppressants make more sense. They include calcium chloride, magnesium chloride, resin products, enzyme products, salt, cement, and other agents. Their use is cost-effective when the amount of traffic on a road is high. These palliatives suppress dust by helping the gravel particles bond together, not allowing the fines to be picked up by traffic and raised as dust. Chloride products, for example, attract moisture, absorbing more than their weight in water. This retained moisture holds the gravel particles together. The difference between treated and untreated surfaces can be remarkable, as you see here. Prior to applying any palliative for the first time, it should first be tested by constructing a test strip on the road to be treated. Recommended application rates and procedures should be followed, and the results should be carefully noted. The handbook contains more information about palliatives. Next, the loss of sinking gravel can be prevented by making sure that subgrade materials and conditions are good when the road is constructed or re-graveled. Otherwise, muck or other poor roadbed materials will soon begin swallowing up the surface gravel. Another preventive measure is to provide adequate drainage. Of course, that's easier said than done. In some places, in some seasons, it's nearly impossible to keep roadbeds dry enough. But to stand a chance, roads have to be constructed and maintained to keep water off, out of, and away from them. To correct the effects of habitually wet and unstable sections of road, geotextile materials may be installed between the problem roadbed layer and the gravel surface. The handbook discusses this type of solution. Finally, let's look at rutting. The condition that leads to the material loss just described results in another type of gravel road problem, rutting, and, to a related problem, potholes. Ruts are longitudinal depressions that form in wheel paths due to a permanent deformation in any road layer or the subgrade. They create an uncomfortable, perhaps treacherous, riding surface, and they lead to further deterioration of the road. Slight rutting may be due to normal traffic wear on the gravel surface. Ruts may also be created where some of the surface gravel is dislodged. With wet roads, though, rutting often becomes severe, all the more so when the roadbed has a high clay or silt content, or when it has excessive fines. In the case of high clay content, here's what happens. The live loads exerted by traffic on the wet road cause the water and clay to mix and form a paste. Traffic also creates a suction that pulls the paste upwards into the surface course. Normally, in dry conditions, the gravel particles hold firmly together by friction. But when the clay paste is pumped up from the base into the surface, it coats the gravel. The particles become lubricated and lose their friction, allowing their surfaces to slide past each other. So as the gravel is pushed down into soft, wet material below, severe ruts develop above. Now, the wet conditions that contribute to rutting may be caused by inadequate roadside ditches, poor crown, weak roadbed soils, or a high water table. Potholes are related to ruts, bowl-shaped depressions usually less than a meter in diameter. They are produced where traffic wears away small areas of the road surface or where soft spots develop in underlying soils. Water or excessive fines in the road contribute to pothole formation. And potholes grow faster when water sits in them. The problem becomes severe when potholes cover most of the road surface. The best way to prevent serious rutting is to maintain the road's crown, ditches, and culverts properly, assuming that the subgrade doesn't consist of soils that are weak even when dry. As for correcting rutting, slight to moderate rutting can be corrected by blading the surface and restoring the crown. Severe rutting often calls again for improving the road's drainage. So cut ditches and install culverts, or clean or replace existing ones as necessary. And just as with sinking gravel, severe rutting may also be related to subgrade conditions. Excavation into the roadbed and replacement of existing foundation soils with more stable free draining materials may be required. Once drainage and roadbed problems are solved, new gravel should be added to the surface and properly shaped. Another possible solution is to add materials such as dust palliatives to stabilize the existing gravel. As for potholes, isolated ones can be repaired by hand, by cleaning up the depression, filling it with well-graded granular material, and then compacting the patch. Extensive potholes require reworking and major regrading, usually preceded by scarifying. Well-graded granular material is often added. The scarification beforehand ensures a good blend of the existing material with the new. But even when new material is not added, the scarifying is needed to form a new crust. In the process, moisture may have to be added, and the road may need reshaping to restore the crown. Drainage improvements will likely be needed too, to restore surface stability and prevent future potholing. Potholes, ruts. Gravel lost by sinking, raveling, or dusting. Washboards. These are common problems of gravel surfaced roads. You're now familiar with what causes them and how to prevent or correct them. In Part 3, we'll look at maintenance equipment and techniques. In this third and final part of the video program, we'll focus on gravel road maintenance equipment and techniques. Beginning with equipment. The motor grader has traditionally been the workhorse of gravel road maintenance, and for good reason. It's a venerable and versatile piece of machinery that has been gradually improved through the years. Articulation is one such improvement, one that greatly increases the grader's maneuverability and effectiveness. Of course, there are many different makes and models of motor graders. Perhaps within your own agency there is quite an assortment. Not all of them have the same features, including articulation, but all can accomplish the same basic tasks in maintaining gravel roads. Smoothing, reshaping, and regraveling the roadway and shoulders, and cleaning ditches. Let's look quickly at each. Smoothing a gravel road may also be termed blading or dragging. It's a routine maintenance operation aimed at restoring a road's crust by collecting loose fines and gravel and respreading them evenly. The fines and gravel break loose because of normal traffic action and weathering. After this loose material is spread, traffic recompacts it to form a tight crust if moisture is present. Smoothing may eliminate minor surface irregularities, but isn't intended to correct the more severe or extensive defects. Reshaping, however, is. It involves cutting and remixing the surface materials to restore the crown to its original shape. Rather than just collecting and respreading already loose material, reshaping cuts deep enough into the surface to eliminate defects and thoroughly remix the gravel layer. Reshaping is needed when mere smoothing will not restore the surface adequately. For example, following heavy rainfalls or in the springtime. Multiple grader passes are required to properly remix and reshape the roadway, including shoulders. Regraveling is the adding of new gravel to replace material that has been lost from the surface. It's a reconstruction operation that involves more equipment than just the grader, including dump trucks for placing gravel, and ideally water trucks for adding moisture, and rollers for compacting the new gravel layer. Before new material is brought in, the existing surface should be scarified to prepare it to blend with the gravel to be added. Moistening the surface with water is advisable at this point. Then the grader operator usually sets stakes or other markers to indicate the spread distances for truck drivers to dump their gravel. The drivers try to dump their loads from the end of the previous pile right up to the next marker. Next, the grader operator works these piles into an equalized windrow, remixing the gravel to minimize segregation and leaving the gravel ready to spread laterally to a uniform depth. Then the operator begins spreading the gravel by cutting it from the equalized windrow and working it across the roadway. Many passes are required to spread it evenly. Water should be sprayed on the surface during final spreading, shaping, and compacting, both to aid in producing a dense surface course and tight crust, and to control dust. The surface should be rolled after the grader's final pass to compact the gravel layer and to form the surface crust. Now, not all regraveling is of the scope you see here, of course. On this job, enough new material is being added to require 2 lifts, each about 80 millimeters thick. Finally, because of the importance of drainage to gravel roads, ditch cleaning is as critical to road maintenance as are smoothing, reshaping, and regraveling. Cleaning ditches with a motor grader involves removing obstructing materials and restoring flow lines so that water draining off the road will then drain away from the road. So these are the basic tasks in maintaining gravel road surfaces with a motor grader. It takes a lot of skill to operate a grader. One thing that operators need to do well is use the proper gears and speed for working and traveling. In part 2, you saw an example of working in the wrong gear and at excessive speed. As a result, the bouncing grader's moldboard made diagonal corrugations in the road surface. So for both quality of work and safety, graders should work at about 5 to 8 kilometers per hour and travel according to the posted speed limit and actual road conditions. Other safety practices need to be followed as well. Signing and marking work areas. Making sure that graders have the required warning lights, placards, and alarms. Working in the direction of traffic. And observing the operator's own safety by remaining seated while operating, using a seat belt, mounting and dismounting the machine carefully, and so forth. The main tool of graders is the moldboard. Attached to its bottom is the blade or cutting edge, 2 or more replaceable sections that take the brunt of the wear and tear. Moldboards are adjustable for angle, pitch or tilt, and downward pressure. They can be side shifted, or even placed in the bank position. All of this flexibility is for a purpose, to enable the grader to put the moldboard where it's needed to perform the cutting, shaping, mixing, or spreading that's required. Another tool on many graders is the scarifying attachment. It's used mainly to rip and break up surfaces, but also to blend materials together. Seeing the need to make moldboards and blades still more versatile, certain manufacturers have developed specialized scarifying blades. We'll cover 3 of them here. Caterpillar's grader bit system features fixed teeth or bits that are replaceable and have different widths for different operations. The number and spacing of bits can be varied for different uses. John Deere's Stinger system employs round bits that rotate, are likewise replaceable, and can be variably spaced. Sandvik System 2000 is another type of scarifying blade that uses round rotating bits. These bits and the others are made of carbide steel for longer wear and greater resistance to abrasion. The scarifying blades reportedly penetrate, screen, and smooth better than conventional cutting edges. For example, a hard, uneven surface can be cut and leveled more easily. Also, the spaces between bits leave the fines with the gravel instead of separating them. In addition, less expensive pit run material available in some areas can be used instead of more costly processed gravel because the bits screen out the oversized rock and waste it on the shoulder. In effect, the scarifying blades process the pit run material in place. Altogether, scarifying blades may lower maintenance costs by maintaining more road with the same time and effort, reducing machine time and labor costs, reducing new gravel costs, and producing better maintained gravel surfaces. If interested, local agencies should investigate and decide for themselves. Now, in addition to some traditional machines that have supplemented motor graders, such as drags and rakes, there are some new pieces of equipment out there. For instance, Borgen Sales in South Dakota manufactures the Quick-Tack Road Leveler, a scarifying blade attachment for the front snowplow lift of graders. It combines a moldboard and fixed cutting teeth, something like the scarifying blades we just looked at. Then there's this rock picker developed by Glenn Mac Harley that picks up an entire windrow of surfacing material, separates oversized rocks, and conveys them to a truck, and drops the smaller screened gravel back on the road. The problems of shoulder maintenance on gravel roads can be addressed by equipment like the Retriever, manufactured by AVF Rail Tie Limited of Canada. It's a disking machine designed to mulch shoulder vegetation, level berms that typically form along shoulders, and retrieve gravel that has collected there. Traditionally, the grader's moldboard has been used to pull shoulders. But this practice typically creates maintenance windrows that restrict traffic and drainage. We'll look a little more at this issue in a few minutes, but for now, be aware that the Retriever's intent is to avoid creating these windrows. While another new machine, the Windrow Pulverizer, is designed to process the windrows, breaking up the sod clumps and vegetation so that the materials can be spread back across the travelway. This equipment is manufactured by the Canadian firm Triple S Industries. So in addition to the old workhorse and assorted drags and rakes, there are some newer machines that merit consideration by local agencies. Let's turn now to maintenance techniques. It might be more accurate to call these tips or pointers, and some have been touched on earlier in the video. The first one has to do with proper moisture content of gravel surfaces. Moisture is an ally of gravel roads in several ways. It helps bond gravel particles together, aiding their compaction into a dense mass. When a moist surface is rolled, it forms a thick crust that will then repel rain. And as you well know, moisture suppresses dust. The best time to work a gravel road is the day after it rains. In fact, the only time that a gravel road should be reshaped is when it's moist. If nature doesn't provide moisture, the only way you should work on the road is if you're able to put a water truck on it. Sometimes routine blading may have to be done during periods of prolonged dry weather. If so, only very light blading should be done, never cutting or reshaping. If you cut or reshape a dry surface, the next vehicles to drive by will kick out the fines and you're back where you started. Another point, gravel road reshaping should always include smoothing the surface all the way to the ditch line. Leaving even slight ridges of material along the shoulder can lead to the forming of double or secondary ditches. Runoff then won't reach the ditch, but will build up on the travelway and begin eroding it. You've already seen maintenance windrows in this video, and we've discussed them briefly. They're formed and left on roads for two different reasons. One type is created when shoulders are pulled and the clumps of sod, clipped vegetation, and reclaimed gravel are left in a berm along the edge. Since agencies don't want to spread these large clumps of debris across the roadway, and rightly so, they leave them in the windrow to rot and dry first. Then the material can be used to maintain the surface. Another type of maintenance windrow consists only of excess gravel that's usually stored there during prolonged dry weather. When moisture comes later, this material can be used to replenish the surface. But regardless of why they are there, maintenance windrows should be kept to a minimum because they restrict traffic as well as drainage. Some agencies have policies against leaving windrows at any time. Next point. Ditch cleaning and shaping should be done frequently. Proper ditch maintenance is a key to keeping roads in good condition. Even when there's no maintenance windrow or double ditch to block or intercept runoff, blockage in the ditch itself can keep water from properly flowing off and away from the road. Culverts need to be kept open too, usually requiring some shoveling to supplement what the machine can do. Finally, gravel roads need to be shaped to match intersecting roads. Railroad crossings, bridges, and driveways. Loose gravel must be kept off of paved surfaces and bridge decks, and especially railroad tracks. By increasing their awareness of both the causes of gravel road problems and the means of preventing and correcting them, local agencies can improve their maintenance of a vital portion of our nation's highway network, and thereby better serve the traveling public throughout the land. This presentation has been brought to you by the Local Technical Assistance Program, LTAP. For further information, contact your state's Technology Transfer Center.